Hello, ladies and gentlemen. Today we're going to be talking about how to graph a quadratic. Basically, we're going to take a lot of the information we've seen over the past couple of weeks and kind of put it together to create a graph that we're looking at. Now, I just want to warn you guys, when we're doing graphing like this, it's going to be a little bit different than some of the linear graphing you did last year. Last year it was really important to have a ruler, to make sure it's on graph paper, everything was perfectly accurate, all that sort of stuff. With these graphs, we're going to mainly be trying to make a sketch of what the quadratic would look like. Meaning, number one, we're not going to have to use graph paper. We're not going to be using rulers, make sure everything's straight. I mean, it's a parabola we're making, so it's not going to be straight anyway. But really what we're mainly going to be trying to do is to show somebody, call out the important points, and give an idea of what these graphs look like so that somebody can look at it and go, I kind of have an idea of what that graph looks like and what the important points are that I need to know about it, okay? There's going to be kind of two methods we're going to look at today. The first one is called the roots and the vertex method. Basically, if your quadratic has real roots, that's what you need to do. You have to call out to somebody, here's where the roots are, here's where the vertex is, okay? If it's not if it does not have real roots, if it's not factorable in that way, what you're then going to look for is a vertex and then the 2 points that are near the vertex, which we'll talk about in a second how to find those, okay? The first one, the roots and the vertex method, basically whenever you have real roots, this is the method you should choose. The first thing you have to do is you have to find your roots and you have to find your vertex, okay? So what we're going to do is we're going to go ahead and take this and we're going to find each of those things. The first thing I do is to find the roots, obviously set it equal to 0 and factor it, or you can do completing the square or a quadratic formula. I don't care which way you want to do it. This one is factorable though, and pretty easily factorable. So we'll go ahead and do plus 5 and plus 2. And so we're going to get, if we solve this, that x is going to equal -5 and x is going to equal -2. So I know that my two roots are going to be at -5, 0 and -2, 0. Okay, so when I go to make my sketch, those are two of the points that I'm going to call out to somebody to make sure that they see. The other thing I need to find is my vertex. We're going to find that by using our -b/2a. And again, how we find each of these can change based off what we're given, right? If we're given this in standard form, if it was in vertex form, I can just see the vertex and write it down. If it was in the factored form, I could already see, this is the factored form right here. I could already kind of see my roots, so I can just kind of pull those out, okay? So based off of how the quadratic's given us, the details of this could change a little bit based on what we've seen in the past, okay? But for this vertex, we're going to be doing -b/2a, which in this instance is going to be -7/2 is going to be the x-coordinate. And then I'm going to take -7/2 and I'm going to plug that in for x. And so I'm actually going to pull out my handy-dandy calculator here to help me do this. I'm going to be doing -7/2 squared plus 7 times -7/2 plus 10, and I'm going to get -2 1/4, which, let's see, that would be -9/4. Okay, -2 1/4 or -9/4. All right, so that's going to be my vertex. Now, let's go ahead and let's look at how we're going to make this sketch. The first thing you're going to do is you're going to draw yourself a little XY axis. Again, we're not being super concerned about how straight these lines are, about how perfect this looks. We're going to be kind of labeling to kind of do some of the heavy lifting for us in terms of what this is going to look like, okay? I'll plot my roots first because they're a little bit easier to see. We have -2, 0 and -5, 0. So I'm going to go about to where -2 would be, okay? Call that point out. Go out to where -5 would be. And I'm going to put 2 points there, okay? So we'll put a point here. And we'll put a point over here. Again, you can kind of see why this is a sketch. It's not exactly perfect. We don't necessarily have a scale here to tell us where everything is, but we're kind of giving an idea about what this would look like, okay? Then we know that our vertex is going to be at -7/2, which if we think about is like -3.5, which makes sense because that's halfway in between these. So we go halfway in between. That's where -7/2 is. And then how far down it is -9/4, which again is like -2 1/4. So we go down about how far that is. That's where -9/4 is going to be. think I write the number 4. It looks more like a Y. That's 4. Okay, and then that's where we're going to go ahead and we're going to put that point right there. Now, parabolas, they are U-shaped. They're not shaped like a V. Make sure there's not a point there. Make sure they're shaped like a U. So we're going to kind of come down. Again, doesn't have to be perfect, but we do want to make sure it's rounded there and go up. And then just like a line, we want to make sure we have arrows on the end so we can show somebody that this is going on forever. And that's the kind of sketch that we're looking for. Again, somebody can look at this and see, oh, there's the vertex, it's at this point. There's the roots there at this point. I got all the important information. I have a general idea of what this quadratic graph looks like, what the parabola looks like that I'm getting from that function. Okay. So the vertex and the points method, you're going to use this whenever your quadratic does not have real roots, okay? Even if it's not factorable and you kind of get irrational roots, you can still do the previous method. You just have to use quadratic formula or completing the square. And again, we're just kind of estimating and guessing where they are. So you just kind of say, hey, it's about here. That's how I can do my sketch, okay? But if that's not the case, and if we don't have real roots, we have imaginary roots, we would have a problem because I need 3 points to graph a quadratic. If I only have the vertex, I don't have my 3 points. So, Mr. Guy, what do we do at that point? Well, here's kind of what happens. Let's look at an example here. First of all, I can use my discriminant that I've learned about, okay, and that can kind of tell me how many roots I'm going to have. So my discriminant, if you remember, is b squared minus 4ac. And looking at this one, if I go ahead and plug this in, b squared is going to be 16. And then minus 4ac is going to be, let's see, we're going to have negative 2 times negative 5, which is 10, times 4 minus 40. I can kind of see that I am not going to get a real root, right? It's going to be a negative number. Negative means there's no real roots. Uh-oh, Scooby-Doo, okay? So what do? Well, I don't panic. I first just go ahead and I find my vertex. So to find my vertex, I'll do negative b over 2a. So this will be negative 4 over 2 times negative 2, which we know that negative makes it positive. So 4 divided by negative 4, I'm going to get negative 1. That's going to be the x-coordinate. And then I go ahead and I plug that in to figure out what the y-coordinate is going to be. Negative 1 squared is 1, so I'll get negative 2 plus 4, which will be 2, minus 5. We're going to get negative 3. Okay, so that's my vertex. All right, cool. Got that. Well, what about the other 2 points? If I don't have roots, what should my other 2 points be? You're just going to pick 2 numbers right next to negative 1 on either side. So I'm going to go ahead and I'm going to pick 0, and I'm going to go ahead and pick negative 2. Now, here's what's cool about this. Your parabola is symmetrical. Remember, we talked about how the axis of symmetry runs right through your vertex. That means whatever y value you get for one of these points will also be the y value for the other. Now, I do suggest you do plug it in both times just to make sure you did it correctly, because you don't want to be wrong once and then just get the other one wrong too. But if whatever you get for one should be the same as the other. Good way to kind of check and make sure you did it correctly. So for example, when I plug 0 in, I'm going to get negative 2 times 0 squared, 0. Minus 4 times 0, 0. Minus 5, negative 5 is what I'm going to get as the y-coordinate. For the other one, when I plug negative 2 in, we're going to have 4 times negative 2, which is negative 8. And then we're going to go ahead and we're going to add 8, which will give us 0, minus 5. Oh, look, I got negative 5 again. These are the 3 points I'm now going to go ahead and graph. So let's go ahead. Let's draw ourselves an XY axis. And I'm going to go ahead and I'm going to plot these 3 points. So my first point I'm going to plot is going to be negative 1, 3. I'll go out to wherever I say negative 1 is. I'll go down to the negative 3. And I'll go ahead and I'll put my point here. I then see I have 0, negative 5. So we'll be at 0. We'll go down to, we'll call this negative 5. And I'll put a point there. And then I also have negative 2, negative 5. We'll go out where we say negative 2 is. Go down to negative 5 and put a point there. You'll notice this parabola, when I go to draw the U, is actually facing downwards, which makes a lot of sense with the equation that we had, because if you looked at the equation, we had a negative leading coefficient That's what's going to make your parabolas open downwards, okay? Positive leading coefficients, they'll open upwards. Negative leading coefficients, they'll open downwards, which as we can see with this one right here, okay? So that's how we're going to graph quadratics. Again, we're just kind of making a sketch. That's kind of our goal. Thank you all for watching.